Jojit. So we're going to be the faculty coordinators this year, and Sang and Penny are our graduate student coordinators. They've been doing a great job getting everything ready and getting all the logistics going for this year. One point I should mention with regard to logistics, we now have a subscribable Google Calendar, so if you want to see who all the upcoming speakers are, you can go onto the MISP webpage and add the Google Calendar to your calendar so that you get all that information immediately. The other thing that I wanted to mention, and I'm really glad that everyone seemed to have gotten the message that we're starting now at around 11:30, so that we have more time for lunch and more time for mingling before talks, and then we can start talks right at 12 and have more time for questions after the talks. So we're trying out this new format, and hopefully you all agree that it works, or tell us that you hate it and we tweak it a little bit. Anything else?
So, one last thing is that we are usually always meeting on Tuesdays and have the entire fall semester set up. We'll be working a little bit on the spring schedule as we work out what other talks look like. Except that this week we do have another talk on Thursday. So Nathan Matthias from MIT is going to be here on campus and will be giving an off-schedule MISP talk. So you'll hear and get a flyer about that. All right. So having said that, we are delighted to set off with our first speaker, Alan, who is right here.
Okay.
Yeah, there's a swap button. Can you just hit play from start? And then up at the top, the third button over to swap display. And show each slide so it'll show and swap display. There you go.
You can't see that.
So welcome everyone. It's a real pleasure to see so many people present here. My name is Alain Cohn. I just recently started as an assistant professor of information here, so my training is in economics. I consider myself a behavioral economist, which is a mixture between economics and psychology. But my work is very interdisciplinary, so it's not only I not only borrow from psychology, but I also use tools from other fields like sociology, biology, and so on. So my work can be broadly divided into three areas. So the first area is about studying about why people behave dishonestly, or when do they behave honestly. So the question is here how external motivations, like for example incentives, affect people's honesty, but also the internal forces, because very often you're in a situation where no one is watching you, and so the probability that you're getting caught and punished is basically absent. And so what forces restrain you from behaving dishonestly? A second area that I'm also very interested in doing research in is labor economics, so basically understanding how organizations function and how to motivate, for example, employees. So my very first study was about whether increasing the wages encourages employees to work harder, to provide higher effort? And the answer is actually not so trivial. Finally, the third area that I'm interested in is behavioral finance. So it's understanding how investors make financial decisions through the lens of psychology, basically. So for example, if you experience stock market fluctuations, how does this affect the way you invest in the future? Now, I think the main characteristic of my work is that I use different experimental methods, often also in combination, because they have different strengths and weaknesses. So for example, I've conducted classic lab experiments with students where they sit in front of a computer and make decisions and interact with each other through these computers to earn money. Of course, there are drawbacks of doing this kind of research. For example, one could ask whether the students are the right population to study, or whether this highly controlled environment mimics the real world sufficiently. So, to address these potential drawbacks, I've also conducted lab in the field experiments, which is basically a lab experiment but with non-standard subject pools, like, for example, prisoners, children, bankers, and so on. So I've also conducted online experiments, but clearly my favorite methodology are field experiments. So field experiments are experiments where people are observed in the natural environment and they don't know that they're part of an experiment. So, because I don't have much time, I just wanted to talk about one specific study, and I thought which study to show. Well, I thought the one that is probably best known. So I did a study on business culture and dishonesty in the banking industry that was published 2 years ago in Nature. So the question that we wanted to address here is whether the norms or the informal rules of behavior in the banking industry, whether they encourage dishonest behavior. So we've all heard about these scandals in the financial industry in recent years, and so there are a number of people who raise concerns about the culture in this industry. So for example, there was an interview with a trader who was then caught cheating and then I think was also sentenced to go to jail. So basically, when he was interviewed, he said the culture of the trading room was to make as much money as possible, as quickly as possible. Clearly, I let myself enter a spiral, in large part because my superiors, seeing the money coming in, did not stop encouraging me. Another quote by Adair Turner, who was chairman of the UK Financial Services Authority, said that bank executives faced the challenge of setting clearly from the top a culture which tells people that there are things they shouldn't do, even if they're legal, even if they're profitable, and even if it's highly likely that the supervisor will never spot them. So this is again like situations where standard economic tools, monitoring and punishment, don't work, and the question is what motivates people to behave honestly or not. So many people raised the possibility that culture in the banking industry is a problem, but the question is that true? Now, how to measure whether this is true? So intuitively, we could just compare different professions and measure their behavior and see whether they differ. So you could take, for example, bankers, measure whether they behave honestly or not, and then you take, for example, insurance people or, I don't know, like medical doctors or whatever. Now, this intuitive approach, while may sound appealing, might be problematic because of two reasons. First of all, so you have selection effects. Different people select to work in different professions. So if you compare the behavior of different professions, you don't know whether these are just different people or whether it's the environment that shapes their behavior. The second problem is to really know that it's the culture and not something else. So it could be the incentive schemes, it could be learning and so on. So there are many factors that could affect people's behavior, and so we don't really know whether it's the norms that are present in the work environment. So in this paper, we chose a very different approach based on an older theory from psychology, which was then taken up in economics. So the idea is based on identity theory. So identity theory posits that people have multiple self or multiple social identities with which they associate with. So for example, you can have an identity, so as a man or woman, you can have an identity of being black or white, or having a certain profession, and so on. And these roles or identities are tied to norms that prescribe how you should behave in particular situations. Now, as I said before, that you can have different identities, so for example, a professional identity and more private identity, that the way you behave at home. Now, these different identities may prescribe different behaviors in the same situation, so they might be in conflict. And so the question is, to which identity you're more likely to adhere depends on the salience of the particular identity in your mind. So for example, if your professional identity is more salient in your mind, you're more likely to behave according to the rules or norms set by your professional identity, and otherwise could be the same could be true for your private identity. So the idea here was to manipulate the saliency of the professional identity, which is associated with the business norms, and this is exactly what we wanted to measure. So how did we do it? We ran an experiment with bank employees. We randomly assigned them to two conditions. One was the professional identity condition, the other one was the control condition. In the professional identity condition, so they participated in an online survey, and then we asked them a few questions about their professional background. So they didn't really know what was going on, but on the subconscious level, their professional identity and the associated norms with it, which is what we wanted to measure, were made more salient. And so we asked them, for example, how long have you been working at this bank, what is your function, and so on. In the control condition, we asked very similar questions, but about very different topics. So we asked them what you do in your leisure time, where were you in your last vacation, and so on. So these 7 questions were the only difference between the control and the treatment group. And then we measured dishonest behavior. How did we do it? Well, we asked them to take any coin, flip it 10 times, and to report the outcomes. Now, for each coin toss, we told them exactly whether heads or tail would give them a monetary payoff. So, for example, in one situation, for one coin toss was heads would give you $20 and tails would give you nothing. So they had to repeat that 10 times, and so they could earn up to $200. So the incentive here to not report the truth was considerable, was relatively high. Okay? So no one could observe you cheating. You could have just claimed to be successful 10 times and walk away with $200. Or you could be honest, and then in expectation, you should be successful in 50% of the cases. Now, we don't know whether a single participant cheated or not. So it's truly hidden behavior. However, based on basic statistics, we know that on expectation, we should expect 50% successful coin flips and 50% unsuccessful coin flips. So, because I'm running out of time, here are the results. So blue is the binomial distribution based on if everyone will behave or report truthfully, this is what we should expect. Okay? Red is the empirical distribution that we found in the control condition. So what you can see is it's very close to the honesty benchmark. In the control condition, we see a few people cheating and saying like they had 10 times the right outcome, but overall the cheating rate is only 3%. So, to our surprise, and I think to the surprise of many, bankers were actually very honest in our experiment. However, when we made their professional identity more salient, the distribution shifted to the right. So we had many more people claiming to have won on every single coin toss, and we also had more people saying that they had like 6 or 7 times, 8 times successful. So the implied cheating rate was 16% in the treatment group. So From this, we concluded that norms, so the informal rules of behavior that are prevalent in the banking industry, that they encourage dishonest behavior, but that bankers themselves might not be very dishonest people. Okay, thank you.
So no questions, because we'll do a panel at the end where you can ask questions to everyone, so keep your questions in mind. Next up, we have Libby Hempel.
Hi.
Hello.
That was really enthusiastic. My name is Libby Hempel. Thank you. I am an associate professor. My PhD is from SI, so yes. There should be something there. Matt mentioned that maybe later one of the questions might be about how did you get where you are, so I'm happy to talk about how you come back, or don't, depending on where you're from. So I'm going to talk briefly about my research, which is today about sort of the connections between social media and social change. I'm especially interested in the arrow going that way, so how does social media bring about social change? But I won't get too much into the politics. The motivations behind why do I study these things is that I'm especially interested in issues of power and access. Who has it? How do you get it? What are the implications of who has it and how you get it? I think that social media is doing a little bit of disruption, which is maybe not the word I should use, but social media is sort of biting at the edges around these issues of power and access, and I think it demands some of our attention. And I'll talk briefly about 3 example projects that I'm working on. One about how nonprofits manage information about events. Second, about fans advocating for representation in media. And the third, sort of in order for social media to be useful for social change efforts, we have to be able to use social media in the first place. And so I'll talk a little about a project I work on about making social media conducive to discussions. So this first one, the point is not for you to know what all of these icons are, but to see that there are a lot of them. So this is from an interview study with 26 nonprofit social media managers in a large city in the Midwest, asking them sort of when you're planning an event, what tools do you use to plan and execute that event and then use it after? And so this is from the beginning of their sort of event planning to the end, them talking about which tools do you use at what times. We thought we'd maybe see 5 or 6 tools. We saw over 30, so that's more than 1 per person, and every person reported using 4 or 5 at minimum. And this tells me that there is an information problem here, that there's probably some loss and some confusion about sort of who are the audiences, where does the information go, which information do we need from beginning to end. These are the sorts of questions that I'm interested in asking of this data. So this one is sort of a work in progress as we try to understand the conditions under which each of these tools accomplish some need. And we're using a couple of theories to try to understand theories of individual technology choice, like task technology fit, or uses and gratifications, or social capital theories, signaling. Do any of those help us understand how organizations make choices about technologies? Or are they just groups of individuals? Those are the sorts of information questions here. The second study so I'm especially interested in queer fans, but also other marginalized groups of fans, and how do they advocate for representation on television? Because representation matters. It has a normalizing function that is especially important for marginalized groups to be seen as normal, and it helps us become less marginal. And this is an incredibly straight activity between 2 really straight friends on the TV show Rizzoli and Isles. And I say that somewhat sarcastically because the people watching the show didn't find it all that straight. And sometimes when we're talking about queer representation, we're talking about advocating for more queer characters. Sometimes we're sort of showing you just how queer some straight stuff really is. And Rizzoli and Isles is one of those places where that happens. So I have, I'm working on a paper about Rizzoli and Isles subtext readings especially, but I'm also interested in other fan movements, like LGBT fans deserve better, that are ways in which fans try to advocate for representation by appealing both to other fans and to producers, and in the Rizzoli and Isles case, to actors. that how are ways that we get better representation. And social media is a mechanism through which fans who have very little power except through watching are actually showing that they do have some power to influence what gets produced and what stays on the air. So that's that one. This one, because everybody likes a good graph, especially a machine learning model here at SI, here's one that I worked on. So this is, we're trying to predict, so this reports on one task, which is hostility presence prediction. So in an Instagram comment thread, how likely is it that a hostility or a hostile comment will occur, given the stuff that's come before? And then various models of which features to include, and I can talk about each of those particular collections of features. We did a second task here as well, which was to predict the intensity of the hostility that will occur. So given the first hostile comment, how likely is it that N hostile comments will occur later? And the idea here is that, according to sort of argument theory, good civil comments produce more good civil comments, and hostile aggressive comments produce more aggressive hostile comments. So in a particular thread, if we can predict the sort of when will the conversation tip, we can interrupt the conversation. So the conversation doesn't have to stop, but we might be able to introduce something like a pause. Ooh, sorry, a pause button, or a social bot, or a high power person could come in and say, hey, somebody is receiving that comment. Or maybe you should take a break before you send another really mean thing. And so the graphs here, we're using area under the curve, and you can, this is the, down along the bottom is the lead time. So we varied sort of how far in the future are we predicting a particular hostile comment. And hostile, we had mTurkers rate the hostility, and then we used a voting mechanism. So we had every comment rated by at least 2, and then we had a third break tags. That's pretty simple, just labeling on hostility. And we had them go through a training program to become certified hostility detectors. Because turns out that there's a lot of disagreement about what counts as hostile or what counts as bullying. So behind this project, and why would I get involved in machine learning modeling, is that I think that we have a real problem with, a real challenge of problem definition. That there are lots of different ways that people are terrible to one another online, and we need to kind of catalog and describe their fundamental characteristics in order to be able to model them. And so this is just a baseline of like hostile or not hostile, and then how much occurs, so that we can do more fine-grained detections of particular kinds of hostility like hate speech or dogpiling. That we can't detect those other kinds of hostile and aggressive behaviors if we can't at least find our baseline. So there you go, 3 projects and me, and I look forward to questions.
All right, thanks so much. Next up, we'll do David Jurgens. We're stopping.
All right, so I'm David Jurgens. It's been a long journey. You can ask me if you're curious, but I work on language, people, and networks, so that's kind of the thing I want to talk to you today about. Give you the greatest hits tour of like 2 interesting things I worked on, and then 3 quick things that I'm currently working on. So my research, you kind of get the big picture of publications in keywords grab your eye. It's language, networks, and human behavior. If you think about that in terms of fields, it's like natural language processing, network science, computational social science. I think the exciting part is right in the middle. So I'm going to talk to you about 2 papers looking at, are we being socially representative in a very boring NLP task that actually ends up being not socially representative, and then looking at group behavior in terms of how do the interaction of linguistic and social features actually affect our behavior. All right, so if you think about your typical social media analysis pipeline, you get some multilingual text, you pass it through a language identification system, and then you do some analysis. And then what happens? Well, all the non-English stuff just goes to the black hole, and you're like, well, YOLO, you know, you just kind of keep moving with your life. Well, and so we're like, okay, well, what is this actually doing? What kind of language are we really identifying? So we said, well, one thing we could be doing is just finding the Queen's English. So, you go to Twitter and you're like, well, there's the Queen, there's her English. She's talking about swan upping. Very natural English phrase to occur. But then you're like, well, okay, no, this is, be serious, David. This is social media. You expect things like this. So the problem I have with reporting is it's too literal. Everyone knows people talk different everywhere. You know what she means, just like we do. There's like one word that's spelled right in that, but we can still read it. So if you're like, good luck if you're a language ID system, right? Maybe just like, let's toss that one out. But language isn't just this. It's not like a spectrum of like literally the Queen's English to something else. You get things like this. So there's a person talking in their local dialect, so you get this dialectic speech, and then you get on the right side this code switching. So you get people actually switching between two languages. And this isn't like some sort of like weird anomalous language. This is people talking how they actually talk. So it turns out the Queen isn't the only English speaker. There's like tons of them across the globe, and they're sort of just speaking how they naturally do. So we said, okay, well, how are we actually catching this kind of stuff? And with this actually a big social problem. So if you fail to recognize the language, well, it means you're silencing entire groups of people. So this is how you speak in, like, say, Cameroon, where English is a national language. Like, wow, you just may be missing all of Cameroon. That sounds pretty bad. So we said, let's try and measure this. Not a really easy way to do this, but we said, okay, on the y-axis, I'm just going to show you for English. Y-axis is how good is a language detection system for English. On the x-axis is going to be human development index. So I work on linguists, so you can draw upon some social linguistic stuff. It turns out we get less dialectic speech. The more developed you get more dialectic speech. On the less developed you get. So just to ground these, you get like Nigeria around a 0.5, India's a little over 0.6, and Australia's a 0.9. And sure enough, all the current systems that we use literally in our research, we actually scoured Google Scholar. No one has ever retrained these, which is a bit sad. So you start doing worse overall, which is a bit unfortunate. So it turns out that's up to a 23% gap. But if we do what we do, so I'm skipping over all the gory details, but if you get socially representative data and better machine learning models, we actually went to the deep learning phase of things, you can actually like bump this number up quite a bit and actually reduce the disparity. So this is kind of an encouraging thing. Like actually representation matters at the performance level, but also at the social level. And not just that, actually like gives you a huge performance boost. So you get some easy wins, like numbers go up in tables. All right, so we got that, and so let's quickly move on to this group behavior thing. And so how does like if you have the social aspect and you have the linguistic aspect, how do they work together? So question answering is like this thing that we do all the time on social media. So here we have like a person asking their friend, but also you're in groups and they're sort of like just in peers. This is like a fundamental thing. This is like how we program. I mean, I literally, this is not examples. This is what I do all the day. I figure out how to find a directory in Python. So I can't figure out how to do it. So I have to go and I ask a question. And so we said, well, what social factors actually affect this? So in social media, we have all the different kinds of ways we can do it. We can ask our followers, we can ask people, we can ask groups directly. And so it turns out we have a great website that I'm not going into that lets us look at all three of these things together. And it's got super rich demographic information. So we have age and gender and like social status. And we have all three of these. So we said, okay, well, let's predict which questions actually get a response if you ask for help. So just quick modeling. So we do actually do this huge logistic regression or logic regression on linguistic and demographic features too. Just to give you the quick highlights, well, actually, so we can think, well, there's lots of theories actually that figure out what we should be doing. One is that it's social capital. Everyone likes social capital theory. If you're high status, you should get an answer. But it could be that it's groups, right? We're in a social group, and that provides group affiliation benefits. There's a sort of tribalism that comes with that. So maybe the group's the driving factor. But it could just be like, your mom says be polite, and you ask them something really nicely, and like, sure enough, you get a response. This is like a thing. At least is what my mom tells me. So we said, well, let's try and like play into the theory aspect of this. So what I'm going to show you is just 4 regression coefficients for each of the different conditions. Not shown is a ton of linguistic features. There's like, we're controlled for all sorts of stuff in terms of the content and the venue in which it's asked and the people and all that stuff. So that's not shown. What we do, if you look back at theories, we see 2 key things. One is that groups are amazing for reducing social inequality with respect to social status. So the fact that you have no social capital totally doesn't matter in a group. So you get this nice tribalism benefit. Politeness, unfortunately, only helps a little bit, but it does actually matter. Two things that you should see, if you look at terms of gender, if you're a guy online, you're going to have bad time. It turns out females are much more likely to ask questions. And if you have no followers and you ask your followers, you're also going to have a bad time. But if you think about what this really matters, who has no social status and probably no followers online? Well, that's new users. And so if you said, well, how do we get new user support? Well, it turns out groups are a great way to do it. You toss them in the group, and it doesn't matter if they have social status. It doesn't matter if they don't have a lot of followers. And so it's like this key insight that we think can actually help for designing social systems. Okay, so with the two quick highlights, I'm going to give you a quick sense of what I'm currently working on. So one is trying to integrate social knowledge into language understanding. So I do a lot of work on natural language processing, and typically we just are focused on the text. And there's a lot of things that happen. And the purpose of text isn't to understand it, it's to get someone else to understand what you meant when you said it. So I want to give this example. So say your professor says to their student, please study the material before class. Totally reasonable. The student goes off and reads it. If you flip that around, and the student says to the professor, please study the material before class, that might not go over so well. But you really have literally the same utterance. It's like if you just looked at the text, there'd be no way of telling whether that's offensive. And so really what we're getting into is this notion of social roles and the fact that there's a bigger social context and power dynamics, and all sorts of social status effects that come into that. So we're actually trying to build language understanding systems that use this broader social context to do things, especially with effects for condescension. So there's all sorts of different toxic language that doesn't get detected because it's really positive on the surface, but man, it has a super detrimental impact. So that's the goal there. So I want to talk about a little bit about social relationships. Not everything, if you think things you would tell your friends but not your mom or your dad, there's all sorts of different things at the intersection or at the difference there. But I want to picture, have you ever been in a situation where you have a new person in your social circle, and you're not sure what their interests are. Say you're Jon Snow, and you're like, what's going to happen here? It turns out that relationships carry different linguistic and social expectations, how those actually evolve over time. And so we were curious, how do we actually figure out what these are if we want to look at the evolution of different kinds of social relationships? So what we did was actually scrape and put together this data set of around 30 years of television scripts, in interactions and dialogue and social roles. And we're starting to actually look at how different social networks evolve and how the language changes as people switch their social relationships. All sorts of cool stuff you can do there in terms of looking at social representativeness and how people's roles actually are representative over time. All right, and then last, you can think about what's the most important issue in today's society. I think all of us would have different answers for that. You could take a survey of people on the street to figure out what they would say. But we're looking at this broader topic from communications theory called agenda setting. So it's how do you figure out what is the most important thing? And specifically, how does social media affect what the average person says is the most important thing? So it's, you have your newspapers and you have the government, but social media is sort of this equalizing force where all sorts of stuff can come into play. All right, so that was the overly long talk, but I'm happy to talk with any of you. Feel free to swing by my office over in North Quadrant and email me. Thanks.
Okay, next up, Patricia Garcia.
Platforms. Hi, I'm Patricia, Pat for short, and I'm standing over here. Can you still hear me?
Yes.
Yeah. Okay, because I'm way too short, you won't be able to see me. I'm starting as assistant professor. Oh, it's a good idea. Oh, yeah. And so I want to talk a little bit about my research. So I think one thing to know about me is that I conduct interdisciplinary action research, and the two domains that I work in are education and information. And I do this for the purpose of thinking about the relationship between technology, learning, and teaching, and all for the purpose of designing what I call culturally responsive computational learning experiences, and I will describe what that means later. So the two main research questions I answer with most of my projects are these two. So first is how can you leverage, how can educators leverage girls' cultural strengths to design effective computational learning experiences? And so this motivation comes from the fact that we've been kind of for decades now trying to engage more women and girls in computing, and the growth has been extremely slow in the areas where there has been growth. And I kind of posit that some ways to engage them is to not focus solely on the technology as the sole reason for doing something, but really using their cultural strengths as an anchor for that learning. So it's an engagement strategy and something that also gives more meaning to the learning. And the second question is how you can actually merge these computing experiences with cultural practices in a way that I kind of said before, anchors this learning in girls' lived experiences. So you're not learning technology in a vacuum, but you're learning about computing within the context of your own life. Okay. So I'm just going to talk about two projects. The first project is my longest standing project up until now, and it's actually a collaboration with a center in Arizona called the Center for Gender Equity in Science and Technology. And let me see where my next slide is. Okay, yeah. So this project is, like I said, a collaboration, and we're working on designing a program, and it's a program that already exists, but it's going through a major redesign. It's called CompuGirls, and it has these three, so it's a program for girls that are ages 13 to 17, and it has these three modules that the girls learn. So they learn co-robotics using a now humanoid robot. They learn digital storytelling using all different kinds of digital media tools, and they learn programming, and because of some of the younger ages, they learn visual programming, so they learn things like Scratch predominantly. And so I was brought in to really start thinking about how, like I said, we could take these kind of computing concepts and skills, but not necessarily send the message that the girls were somehow lacking or deficit because they didn't have these skills. And because research has shown that when you kind of go to a student for the first time and you say, oh, okay, let's kind of have a laundry list of the things that you don't know, that's not a very encouraging place to start. And so instead you start from kind of where their strengths are and what they do know, and use that to anchor the learning, then you are more likely to get engagement in the learning. And so I wanted to experiment with this theory that exists in education. It's called culturally responsive pedagogy. And like I said before, it's about valuing cultural wealth and also shaping your teaching practices so they're reactive to that cultural wealth. And so essentially what I did is I did a lot of research on what people were doing in terms of thinking about cultural responsiveness. And I will say that there is very little research about using cultural responsiveness in a computing and education context. A lot of it has to do with language acquisitions. You can think about English language learners and how research has been done about, if you have someone who's a newcomer to the country, using their culture as a way to engage them in learning the English language. So a lot of work is there, but very little work in computing. And so to me it was really interesting to, because I think people think of computing as something that's very like an objective process, like you either know to code or you don't know how to code, or you know how to design hardware or you don't. And so I think that's why people weren't necessarily thinking in the realm of education about using this strategy with computing. And so these were the four, there's many strategies, but these are the four that I use in this particular program. And I'm only going to talk about two. Sorry, just a little bit about the study. So what I did is I redesigned the program using those four characteristics, and I made sure that they were explicit in the design of the program. And then I piloted the program. So there was kind of like a 1-year development of designing the program. Then I piloted in 3 different states. So Arizona, Colorado, and New York. And there was 60 participants total across the 3 sites. I interviewed 20 of them before and after, and I observed them throughout the entire period, which was about 89 hours of observation. And so I'm just going to show you a little bit about what it looks like when I say you take these cultural responsive theories and you actually make them explicit in the design of the program. And so from the beginning, an intentional part of the program was that we were not going to start with just the technology up front, that we were going to actually spend some days having the girls think about what they did bring to the table, right? So what were their assets when they got there already? And so one of the ways to do that is to validate their identity, right? So just have them start thinking about who they are in an asset-based approach. And so this is just an example of something that we did here. We had them we talked about intersectionality and all of these, kind of feminist theories, and have them think about who they were, not in terms of like, oh, I'm a student who doesn't know how to code, but who are you in your family? Who are you in a classroom? Who are you outside in your social circles? We have them think about their identity along all of these different kind of, intersecting identity categories. And then, just think really deeply about what do you feel proud of? And part of this, it's not divorced from learning STEM or computing more specifically, because there is other research that shows that when you can connect the learning to their home life, again, it's a way to kind of engage in anger. And so we wanted them to think about themselves in all of these different ways. And once we did start getting to the technology, again, we taught the skills, but we wrapped those skills up in that learning in these culturally responsive strategies. And one of them, another strategy, is to always exhibit positive perspectives on families and communities. So instead of saying, oh, you don't have a computer at home, well then I guess I don't know how you're going to do your homework. Instead of focusing on the deficits within communities and families, that you would focus and engage the families in the process of learning. And so the way that looks in the deployment of a program is that you have what we call these kind of community nights where the girls we call them tech demos, where the girls would show not only to their parents, but to the entire community. We opened it up we advertised it a lot of places, where they could show kind of their family, the skills that they were learning, and this actually helped keep them engaged, because one, like here you have a girl showing her little brother, which is, kind of flipping the script of what we see a lot about technology programs, how to program an Arduino to make an RC card. And the families, like I said, are important, and so them seeing this, I cannot tell you, in interviews, the things that parents said about, wow, I didn't know that my daughter could do this, and then them saying, I'm so proud of you, and that, just those things really helped with attrition rates. So before we had high attrition rates where girls were not coming back to the program, when you involve the families, they come back, because the parents kind of see the result of what they're learning. I have no idea how much time. I'm going to skip that. Okay, I'm going to skip. Maybe I'll skip all of that, sorry. I'm just going to talk about what I'm doing now. What I'm doing now is a new project that partners with libraries to kind of take the same concepts but apply them out of school in a library context. And so it's in these 3 states, which we'll talk about later. The aims are to teach these 4 computational thinking skills and to do them in a sustainable, low-cost library program that is led and taught by the librarians themselves and not researchers. And so we started by asking librarians what they would need. These are some of the things. They needed it to be low cost. They could not depend on one-to-one computer ratios. So it had to be unplugged, which is an innovation in itself, how you teach computational thinking unplugged. They needed training, and they wanted it to be user-friendly. So my research team and I, one of them is here, we decided to use paper electronics as an unplugged and cheap way to teach this. There's so much I could go into, but I'm not going to. Happy to answer questions. We are in the pilot version of it, and as you can see here, it's merging computational thinking with the circuitry, with the identity exploration. It's bringing all of this together. The relationship is much more complicated than I can explain right now. But we're seeing positive results, and this is round 1, we plan to do second implementation in a couple of months. And so just to end, some research opportunities, because I see a lot of students here. If you're interested in further testing this idea of tactile and unplugged ways to teach computational thinking, talk to me. If you are interested in just getting practice and experience conducting qualitative research in informal learning environments, I'm your girl. If you want to just learn how to co-design and test curriculum in educational settings, And if you're just more generally interested in this idea of leveraging identity exploration to anchor computational thinking and learning.
All right, and last up we have Andrea Thormer. Sorry.
Okay, I do not have very good slides. All right, my name's Andrea Thomer. I just started here this last couple of months, like a bunch of the rest of the people here. I don't have pretty slides and I don't have a great name for this talk right now. I'm generally going to go through an overview of some of my work in this vague area of natural history museum informatics, which might be a topic that I made up. But I'm using it as an umbrella term for a bunch of different areas that I think are better summarized as natural history museum and informatics. But before I get into that, I wanted to tell you a little bit about my background. So before I went to grad school for information science, I used to work at the La Brea Tar Pits as an excavator. So I volunteered there for 4 years, worked there for 3 years, and spent a lot of time just digging fossils out of the ground. So if you haven't heard of the La Brea Tar Pits, it was the home of thousands and thousands of saber-toothed cats, dire wolves, mammoths, giant ground sloths, as well as a bunch of smaller microfauna like mice and squirrels and things like that. It's one of the richest fossil sites in the world. It's important because it's this beautiful record of Ice Age Los Angeles. So the fossils and the data that comes from those fossils is really important in studies of climate change, as well as just evolution over time. So my work at La Brea got me thinking about just natural history museum data in general. So we don't tend to think about museum specimens as being data. We think of them as things that sit on shelves and that we don't get to touch when we go to museums. But they're actually an incredibly rich source of data for a lot of different kinds of studies. And it's a different kind of big data than we also usually talk about. So there's estimated 1 to 2 billion specimens in natural history museums throughout the world. Some estimates have gone up to 3 to 4 billion specimens throughout the world. We have to estimate them because most of them are not cataloged. Most of them have not been really described. Most of them are not actually described in a computer. So this is also big heterogeneous data. So natural history specimens in general includes fossils, rocks, whole animal specimens, bugs on pins and drawers, fish in alcohol jars, and rocks, and all of their associated records. So lots and lots of databases, lots and lots of random spreadsheets, and lots of paper catalog ledgers that are all really difficult to bring together and analyze in one go. A lot of this data is really messy also. So this picture is actually from the back catalog of a museum that I visited. And in any given museum, there's probably hundreds of little cardboard boxes like this, filled with things that are probably fossils, maybe, and might have records associated with them somewhere, and are just waiting for somebody to reunite them with their metadata, basically. You can't get rid of them because it might be informative if you find the record, but for now, it's just a rock in a box until you actually reassociate it with some sort of description of where it came from and why somebody collected it in the first place. On top of that, just this issue of getting the stuff separated from its metadata, a lot of the metadata that does exist in, even when it is in a database, winds up being a little bit messy in and of itself. So a recent study looked at a bunch of names in botanical records and found that 58% of the specimens had the wrong names associated with them in the catalogs. So that was just a small study, but if you extrapolate from like those 4,000 records to, again, that 1 to 2 to maybe 4 billion records, kind of a big deal. So those issues around natural history museum data led to kind of drive my 3 main areas of focus now, primarily in digital curation, so particularly over long-term. Natural history museum collections are usually a lot older than the actual databases used to store them on. And that issue of truly long-term data curation and data preservation is something that we really haven't solved yet.
I'm also interested in information organization, particularly in systems that need to bridge the physical and digital. So again, those rocks and the records about those rocks. And then, and generally that kind of gets wrapped up into this idea of natural history museum informatics. So that can, and that's why I use this, even though it's a mouthful, it's still shorter than saying museum informatics, biodiversity informatics, bird science informatics, paleoinformatics, and other miscellaneous X-informatics fields that kind of can fall under that umbrella. I am already using way too much time. I was going to talk about some of my ongoing projects. I'm going to kind of breeze through them now, I think. So there's three primary areas that I'm doing research in right now. So the first is this idea of site-based data curation. This is what a lot of my dissertation work focused on. Generally trying to curate data from scientifically significant sites. So for this study, I did two case studies, one back at the La Brea Tar Pits, my former home, and another at the Yellowstone National Park, studying how geobiologists collect, curate, and use their data. The primary deliverable from this were these very, very exciting entity relationship diagrams, modeling the main information classes that are needed for what we think of as like data from scientifically significant sites. Traditionally, we found that generally people don't describe the site enough in their records about the data that's coming from the sites. And this information about a site and its structure is really important in actually being able to interpret the data in the future. I'm trying to extend this work with collaborations with some folks at the Earth Science Information Partners Group, so that's called ESIP for short, documenting provenance in data collected at scientifically significant sites by drones, also called SUAS for Small Unmanned Aerial Systems. So this data is really challenging to curate and preserve, both because well, largely because it's coming from drones, but it's not just drones in these workflows, it's usually like 5 other computers that are controlling the drones and then doing the analysis on this. So it's this really complicated workflow in which a lot of the information between the different computers is getting lost as you're trying to transfer things into just one spreadsheet or one database for a project. So I'm extending some of my dissertation research into this area now. I've also been working on a project over the last couple of years, basically studying how databases change over time. So earlier I mentioned that natural history collections are older than the knowledge organization systems that are usually used to store them in. That means that they have to be migrated periodically. So collections that used to be stored in these curiosity cabinets, so that's that green cabinet on the left, back in the 1800s, the collections were organized in a way so as to inspire wonder at God's creation and to make us happy about the world that we live in. As museums started becoming part of the scientific process, these collections were reorganized into taxonomically arranged shelves, organized by the locality from which they came from, things like that. And now they're getting digitized into databases such as the Global Biodiversity Information Facility, things like, I think that top one's from the Paleobiology database. So these collections that were organized around the physical location in the museum are now getting turned into databases, essentially. The questions that come from this are looking at okay, sorry. I didn't write a script for this slide, and I always get lost about 3 minutes into something. So the general idea is that it's not just that we are changing the databases in order to facilitate access to these things, but these databases are changing in response to the use of them, and in sometimes unexpected ways. So I'm trying to ask how databases learn from changing use and users, and one of the ramifications of that is how do de facto administrators cope with the need to change databases when they're not necessarily given administrative control. Let's see. So one of the, this is just something I started working on when I was back at La Brea. This is a very possibly blurry view of the changing databases at the tar pits there. They start out in field notes, they get typed up in typewriters. Eventually they were typed up into WordPerfect 3.1 documents. And now, finally, in this not particularly sophisticated looking database. Some of the case studies that I've been going around and trying to talk to actual curators at these natural history museums and talking to them about the history of the collections that they're working with now. We started out asking how do databases learn from their users. The question I'm now kind of asking is what happens when the databases don't learn? So this picture was taken at the tar pits in about 2008, and this computer was still being used until about 2010. And it was mostly because the collections manager that ran this database did not want to learn any other system. He had a workflow, he knew how to access all of the screens that he needed in the system. You can see there's about 4 little keys in the middle that are particularly grimy, and those are the ones that he used to navigate throughout the different fields in his little WordPerfect template. This picture just came up on Twitter a little while ago. This is Christopher Dick, who's actually now the head of, I think he's at Michigan, and has now helping run a database migration. So if you can't see it, it says save, copy of old fungus database on this machine. And it's on top of a 3.5-inch floppy drive. So basically every natural history museum I've gone to can also double as a computer history museum. This is a picture taken from, I'm going to leave this museum nameless because they didn't give me permission to point out that they have like 5-inch floppy drives hanging out in their collections. This is a screenshot of a currently used collections management database. I have a longer video of this, but this is from a researcher who's been curating a database of chalcid wasps. He's been maintaining this database for at least 30 years and has forced his IT group at the museum to maintain this MS-DOS machine so he can continue using the database in the way in which he is accustomed. Here is an example from, this is again a little custom database that's running in Windows XP. This is a screenshot from a video that was taken last year. So there's this plethora of like devout Luddites in natural history museums, people that have been working really hard to maintain their computer systems as they are because it's too difficult for them to actually migrate them. It would actually break their entire workflow. And these workflows are so complex and nuanced to everybody's individual projects that it's prohibitively time-consuming to it has been so far prohibitively time-consuming to try to migrate it to other things. I'm way over time, I'm really sorry. Anyway, so right now I'm working on trying to do more work in transforming some of these curatorial interfaces, while recognizing that people are working in them because they feel that they need to, and they're really important to their workflows. The data that's in all of these systems is highly at risk. MS-DOS, Windows XP, all these things, most of their IT groups really do not want to be maintaining this. So I'm generally looking for some collaborators in this work too, particularly folks with interest both in data curation and in HCI, UI, UX sorts of things. So, and sorry for taking so much time. Thank you.
We will really quickly, are you guys able to hang around like 10 minutes extra? Okay, perfect. So, ask 5 academics to do 5-minute talk each, and you get 5 10-minute talks. So let's spend a little bit of time now. You guys come up to the front. We will have time, if you have time to hang around, to ask questions of our advisory faculty members, and hopefully get to learn a little bit about them. So we just reorganize for a minute. Does anyone have any questions they might like to ask? Yes.
My question is for Alain. So when you said you did lab in-field experiments, especially you had a very broad category. You had prisoners and people who work in banks. So how did you go about reaching out to them? I'm guessing an email wasn't sufficient.
Yeah, I mean that's always a tricky part. So I think what often helps is if you know someone. So for example, the study that I presented in collaboration, like the first one was collaboration with One March Bank. We had a PhD student who worked at a cafe where the CEO took his coffee every morning, and so this is how the connection started. It can also happen in a more structured way. So there are workshops where firms attend, where firms and academics mingle and try to start collaborations. For example, in Chicago, there's the Advances with Field Experiments every year. So there are a number of ways how to get in touch with companies or unusual subject pools, but but it's different every time. And to me, like the most successful way to do it is if you know someone, if you have a big side.
And are there any incentives that have to be provided to get them to participate?
Well, sometimes we paid for the project, so the company didn't have to pay. Sometimes we asked the company to pay and to have skin in the game. This is typically what I prefer, so that they also provide manpower and other resources, so they're also willing, or they're more likely to support the project until the end. But field experiments are always high risk, high return. So I wouldn't recommend as a PhD student to only focus on field experiments, because you never know whether management changes, for example. I had that a few times, or something else happens. But when it works out, then you often get really exciting results.
Thank you.
I have a quick question for David. So on your last slide, you mentioned about incorporating social knowledge to study the human behavior in the social systems. Can you give us some examples about the social knowledge that you talked about?
Yeah, so I mean, one of the thing we're looking at specifically is looking at condescension right now. So condescension often is due to like a power imbalance between the social rules, but often there's other things about unstated assumptions that are made in the text, and learning how to understand that cultural knowledge. So it's like super nascent work, but essentially one of the big things is it's really hard to detect. So we're building data sets right now to try and actually see what does condescension look like in the wild.
Hi, I enjoyed all of your talks. Thank you very much. I'm Ed Happ on the faculty. Libby, I was really interested in your studying of NGOs and the proliferation of event apps. And I wondered, because having sat in the CIO seat for many years, that was something that always concerned me, is how they proliferate. But I wonder if over time you've looked at those being a function of the growth in choices. And number one. And number two, whether peer pressure plays a role in the selection of apps within organizations.
Yeah, so the first one, this is just a snapshot, so we did all the interviews in basically a 6-month period, so I can't answer that given the short time period of our data. The second one, I don't think that it's peer pressure, I think it's audience pressure. So that it's not that my peer organizations are in a place, but the people who I need to reach are in a place. And so even though, and this Facebook events is the best example. So nobody that we talked to wanted to use Facebook events because it doesn't manage the information that they want to manage, and RSVPs are essentially meaningless. But in order to reach new populations, they had to be on Facebook. And so the audience demanded that they use Facebook events, but there's this tension between, because it's an audience who, the hit rate is going to be really low. So for instance, we were working with, I have permission from all the organizations to use them. So the Albany Park Neighborhood Community Center. So Albany Park is a neighborhood in Chicago. There aren't that many people in Albany Park. It's like this small, about half the size of Ann Arbor. But they wanted to reach seniors, Spanish-speaking seniors in Albany Park. And apparently the Spanish-speaking seniors in Albany Park access Facebook through their grandchildren. And their grandchildren are on Facebook, and that's the only place to reach their grandchildren if you're the Albany Park Community Center. And so they had to go through Facebook events to get to the grandchildren, to get to the seniors, and that there wasn't another way for them to do it. And they hated every step of that process, but they eventually were able to get the seniors to come in to sign up for Obamacare, or to find out about tax relief and earned income tax credit, to take things that they weren't able to reach other ways. So they see it as this sort of evil that's because the audience demands it, not necessarily because their peers do.
Thank you.
I have a question for Patricia. So I was curious about the idea of teaching computational thinking on field, and I was wondering if you could say more about the methodology that you're working with, because I there wasn't a real time to elaborate.
Yeah, so computational thinking is a lot of it, like traditionally has been taught through programming, and there's like a huge debate about what is computational thinking, which I will not agree with, but I chose these 4 different skills, and so for example, one is decomposition, and this is a skill that you apply computational thinking is really broadly like problem solving and critical thinking skills that you apply outside of just computing. But decomposition is this idea of taking a complex problem, being able to break it down into smaller, feasible pieces, and if you're thinking about writing a program, things that could be completed in parallel to each other is one thing that you might think about. So basically we're trying to teach that using things like circuitry. So to say, if you have a complex circuit that you have to build, how, you can't just start from there, but how might you break down that circuit into smaller pieces, and can those pieces be done in parallel to each other? So in a sense it mimics what you would do in a plugged, maybe more programming-based way of teaching computational thinking. We teach about loops, like all of those things. And so, yeah, so I mean, that's just like one example. And so we just take those concepts, have them apply it in a non-kind of online context. And then what we're hoping to see is that knowledge will transfer when we see as kind of like an entryway to other programs that we teach them some higher level skills. So that's just like a quick example.
Is it Andrea? Andrea. Do you think is the major barrier in museum staff like using new software the fact that it's difficult for they're not maybe as tech savvy in learning the new software, or is it more like migrating to new databases is like a huge technical challenge and takes a lot of time that is just too much for them to deal with?
Yeah, I think it's a combination of those things. So most museum staff using anything remotely computer related are completely unsupported in figuring out how to use that. So IT staff in most museums are there to help you send email and to make sure that the Wi-Fi doesn't get hacked. If it's a particularly nice museum, they might help you back up your machine to an external hard drive. There's just not a ton of people there to help them with it. But the database system, so most of these historical natural history databases they're homegrown basically. Somebody learned SQL on their own, created a database on their own machine in their little office underground somewhere, and these people have been maintaining it themselves for years. So they just don't have the time or the professional training to do the migration work a lot of the time themselves. There's also historically been a lot of issues around getting administrators and other folks in the museum to buy into these systems. So a lot of the museums were early adopters of database technology. So in the 1970s, they started putting stuff on punch cards, and that's how a lot of these collections got digitized. So there was usually one early adopter that did all this work and got some volunteers and maybe a little grant money, and then there was usually like a couple people who were highly skeptical and trying to figure out why are we spending so much money on this computer that's not helping me, so we could hire 5 other people. So yeah, there's a whole bunch of issues. It's both they don't have support, they don't have time, and the culture hasn't quite gotten around to seeing it as a worthwhile investment yet, or hasn't historically. Now it's changing a little bit.
Okay, well, excellent. Well, thank you everyone for hanging along with extra time and also for being such a participative audience. We'll have plenty more of these talks, and of course all of them are now trapped in corner them at any point.
Find them if you are looking for, if you're interested in their research and you maybe want to try to get involved. You should totally poke them. I think I can say that.
Yeah, we all want students.
Yeah.
We want people to